Okay, today we're going to talk about proportions and similar figures. When we talk about similar figures, we are talking about figures that have the exact same shape, but not necessarily the exact same size. So we could be looking at, let's say, a triangle that looks like this, okay, and then one that looks like this, okay, and we're looking at them and they are the same shape, but they're just not the same size. But what we always have with similar figures always have sides that are proportional. So they aren't necessarily equal because they are different sizes, but they have sides that are proportional. Now, the other thing that we have to always remember about similar figures is that in similar figures, the angles of the shape must be congruent. They must be the same. They must be the same. So if I'm going to look at this angle here, I'm going to say, well, if this angle is, I'm just looking at it, I'm going to say 89 degrees, okay, then this angle must be 89 degrees, okay? If I come down here and I say, okay, well then if that one's 89, then this one looks to be about 41, okay, I'm picking these numbers because they're easy, so this one is 41, and so 130, so that means that this angle here, 180, so for 120, 130, 180, so this would be 50 degrees. 50 degrees. So, in similar figures, the sides are always proportional and the angles are always congruent, okay? And if we remember in a triangle, the reason why I know this works is that every triangle has a sum of 180 degrees with its angles. So, so that's what we need to know about similar figures. So let's look at if we've got, and let's just use these, and we're going to call this A, B, and C, and this is going to be D, E, and F. Okay, we'll just keep using our same triangles. It'll make it so much easier. If we look at this and we say, okay, so if AC is equal to 14 centimeters, okay, and we know that, let's see, we know that DE, so AC is 14. We know that DE is, let's say that, well, let's go with, I just want to make sure that I'm using good figures for us. Let's say that BC here is 32, and we know that EF is 24, okay? So we've got some measures here, and we just don't know what this FD or DF is. We're going to call that X, okay? So all we have to do is set up a proportion and say, I'm going to say 14 to 32 is going to be equal to X over 24. Notice my 14 is in my numerator. My X, therefore, is in my numerator. 32 and the same side measure, okay, is 24. So now what I'm going to do to make things a lot easier for myself is I'm going to go ahead and I'm going to reduce this, and I'm going to reduce this to, dividing it by 2, 7 over 16. Okay, so when I cross multiply, okay, I'm going to have, and let me move this down a little bit. Now when I cross multiply, I'm going to have 24 times 7 equaling 16x. Okay, coming out of here, doing my side multiplication, keeping my work together, 14, that's 168. And so I have 168 equal to 16x, dividing both sides by 16. Okay, we'll go ahead and do our division. So I have 168 divided by 16. 16 goes into 16 here once. 0, bringing down my 8. And bringing down another 0. Okay, 16 does not go into 8, so there's a 0 here. Okay, there's my decimal point. And 16 goes into 80 exactly 5 times, finishing my problem. And so what I end up with is x equals 10.5. Okay, and so by using a proportion, I have solved my similar figure problem. Okay, so that's similar figures. Now, when we are looking at these similar figures on a coordinate plane, and I'm not going to be using a graph paper, but you'll still get the idea. Oh, I shouldn't wave that quickly because it'll maybe stop. Hopefully we're still going. Okay, so dilating figures mean that dilations are when a figure gets larger or smaller. So the way we're going to look at these dilations, let's say we have a triangle, and let me move this up a little bit so you can see what I'm doing. MNP, and it has vertices of M, 3, -2, and N, which is at 3, 5, and P, which is at -4, -1. And I have a dilation with a scale factor of 2. So my scale factor is 2. So what I am actually going to be doing is I'm going to take every single of one of these numbers and I'm going to multiply it by that scale factor of 2. So what that's going to give me is M prime, 2 times 3 is 6, 2 times -2 is -4, N prime, 2 times 3 is 6, 2 times 5 is 10, and P prime, -4 times 2 is -8, and -1 times 2 is -2. And if I were to graph that, you would see that it pretty much doubles in size. Okay, we're not going to go ahead and do that in these notes, but when you have problems, you'll be able to see that pretty easily. Okay, so that is scale factor and how we use that. Now let's look at some indirect measurements that we will use scale factor and proportions. Indirect measure is one of those that I just really love. So let's say we've got a tree casting a 26-foot shadow. I like to draw these. I don't know, I'm just kind of into the fact that you can draw your tree. You can maybe see it a little bit better. And from the base of my tree, this is 26 feet. It's casting that long of a shadow. Okay, and we've got a boy who's standing nearby, and he casts a 12-foot shadow. So here's my boy. He's going to be a stick figure, and he's going to have spiky hair, and he casts from the base of him a 12-foot shadow. Sometimes when you can see it, you can understand it even better. Okay, his height is 4 foot 5 inches. So his height and I'll just put an arrow there and say 4 feet 5 inches. And the question is, how tall is the tree? How tall is the tree? So that's X. So quite simply, we are going to set up a proportion. Now, what I'm going to do, 4 feet 5 inches is kind of unfortunate. Well, actually, they've got 4, it's 4.5. 4, it's not 5 inches, so it's more 6 inches because it's 4.5. So we're going to use that 4.5 and just, so that would be 4.5 feet. Okay, 4 feet 6 inches is 4.5 feet. We'll set up our proportion. I'm going to go X over 26 is equal to 4.5 over 12. Okay, and we will just go ahead and cross multiply this, and we get 12x equals 26 times 4.5. Unfortunately, we are going to have to switch pages, okay, and continue on the next page, but we know that's okay. So we've got 12x equals 26 times 4.5. I'm going to just check to make sure that I transferred that properly, and I did. Okay, side math, 4.5, that's 0 with 3, and that's 13, and 4 times 6 is 24, and that's 8 and 10, 0, 7, 1, and 1 with 1 decimal point. And so I get 12x equals 117. And now I'm going to go ahead and I'm going to take my 117. I'm going to divide it by the 12. Okay, I'm going to come down here and say 117 divided by 12. It'll go in here 9 times. 9 times 2 is 18. And 10, that's 108. So that's 9 and 0. Here's my decimal point. 12 goes into 90. What? 7? 7 times 74, 7. And 7 times 2 is 14. That's 8. So there's 6. And this works out great because there's a 5 times 12 is 60. And we zero out. So x is equal to 9.75 feet. Okay, so that is how we are going to do, we're going to be doing our indirect measurement, and our final type of problem is going to be our finding distances on a map, which is simply scale and using scale in a proportion. So let's say we have a map distance of 1 inch to 10 miles. So on our map, our scale is 1 inch to 10 miles. And measuring the map distance from one place to another looks like, and I'm just going to have to look at this for you. I'm going to say 2.5. So 1, 2 inches, 2.25 inches. So I'm going to say we're at about 2.25 inches, and we don't know what the actual is, okay? And all I have to do is cross multiply. I get 1x, I'm just putting the 1 there for you, equals 10 times 2.25, which means I just have to move my decimal point one place, okay, and I get 22.5 miles. Okay, so pretty simple there. Okay, so that's it. I know there's nothing exciting in here, and I do apologize for that, but maybe on the next video. Okay, great, thanks.